Welcome, Algebra 1. This video is on quadratic formula. The essential question is, what is the quadratic formula? Let's begin. So, we talked about last video, there's two methods of solving quadratic equations when you can't factor. And we did completing the square last time, but this time we're doing the quadratic formula. Before we do the quadratic formula, we have to talk about simplifying radicals. So when I mean simplify, the left side is a bunch of radicals, square root of 200, square root of 96, and square root of 294. The right side is the simplified version. But how do I get that? And there's a few different ways of doing this. I'm going to show you the method I like. I call it the step method, and it works for me. And it should probably work for you. So first thing you do, if I want to simplify square root of 200, I create a step. So what does a step look like? I actually want to draw it out instead of having it there. The step looks like this. I create a step like that, just like a right angle, and put 200 inside the step. Now, step number 2, you want to factor out a prime number from 200. So some number that goes into 500. And we put it on the left. Since it's an even number, I usually start with the smallest ones I can. I'm going to factor out a 2. So I write a 2 on the left-hand side here, and then I do 200 divided by 2 is 100 and write that below. Since 100, I'll keep doing this process until I get a prime number. 100 is not prime, so I'll make an additional step, then keep going. I can divide out 2 again. So the 100 divided by 2 is 50. And I can do another 2. And divide by 2 is 25. And I can divide that one by 5, and I'm left with 5. 5 is prime, so I stop right there. Now, step number 3, I circle the pairs and square alone. So I'm looking at the numbers on the outside here. Any pair of numbers, you circle. And any number that doesn't have a pair with it, just put a square around it. It's alone. So there I go. Now, when I want to write my radical, I put the pairs on the outside and the alones on the inside. So the radical here, outside, I have a 2 times 2 and a 5 times 5. So the outside, I'm going to have a 2 times 5. On the inside, I just have one radical 2, so I'm going to put a 2 on the inside. 2 times 5 is going to be 10, so my simplified form is 10 radical 2, which is what I said in that last side, 10 radical 2. So those are the steps. I think it just takes a little bit of practice and you'll get it. So let's try two other ones. With square root of 96, if I want to simplify, put 96 and create a step. I can divide that by 2 because it's even. And so 96 divided by 2 is going to be 48. And I can divide that by 2 and I get 24. I can divide that by 2 and get 12. And 2 again and I get 6. And 2 it again, and I get 3. Alright, so I'm going to circle pairs. There's a pair of 2's, there's a pair of 2's. This 2 doesn't have any more pairs, and this 3 doesn't have a pair. So on the outside of the square root, I have a 2 times 2, so it'll be 2 and a 2. And inside, I have a 2 and a 3, so it'll be 2 times 3. 2 times 2 on the outside is 4, and it'll be 2 times 3 is 6. So 4 radical 6, simplified 96. Let's do 294. So 294. Make a step, that's even, so I'm going to divide it by 2, and then I get 187, and 187, that can, nope, that's not even right at all. That's pretty far off. 147, that's better. Now that's not even, so what else can I divide that by? I always check 3's next. I try to go from smallest to biggest. Since all these digits, to check if it's divisible by 3, if all the digits add up to something divisible by 3, then it's divisible. The whole thing is divisible by 3. 1 plus 4 plus 7 is 12, and 12 is divisible by 3, so I can divide 147 by 3. 147 divided by 3 is going to be 14 divided by 3 is 4, carry a 2, that'll be 9, 49. 49 is divisible by 7, and that leaves 7. So that's it, 7's prime. Now I'm going to circle my pairs and square my alones. So on the outside of a pair of 7's, and the inside of the square root sign, I have a 2 times 3, which is 6. So there's my simplified form. Alright, now that we know how to simplify, we can use the quadratic equation. So if you have a quadratic equation in the form ax squared plus bx plus c equals 0, notice you have to have it in the equals 0 form. A, b, and c are some numbers. You can use the quadratic formula to solve it. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. This should be really big in your notes. It should be very obvious because you're going to have to write this a lot. And we'll probably play some songs in class to help you memorize it. Anyways, let's actually use it. So I'm going to solve this problem. 2x squared minus x equals 4. The first thing is I want to put the equation into the correct form. This is not, because we have to put everything on the left-hand side. So what I'm going to do is I'm going to subtract 4 on both sides of the equation. So you're going to get 0 equals 2x squared minus x minus 4. Okay, right form. Now I got to figure out my a, b, and c. So in this case, my a is 2, and my b is going to be, this is my a, my b is right there, and my c is right here. My a, the coefficient is 2, so a is 2. B, there's a negative x, that's like negative 1x, so my b is negative 1, and my c is negative 4. Now I'll substitute into the quadratic formula and simplify. So it's x equals negative b, so negative negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, divided by 2 times a. Now, this is just going to take a lot of steps, and careful your order operation. So it'll be negative minus a negative is plus 1, plus or minus square root of negative 1 squared is 1, minus 4 times 2 is 8, times a negative 4 will be negative 32, so it'll be positive 32, because 2 negatives make a positive, divided by 2 times 2 is 4, and simplifying that again is 1 plus or minus radical 33 over 4. And here's the thing, I can't simplify any more than that. That square root does not simplify. I can't reduce anything, so I'm going to leave it just like that. There's your answer. Okay, so when are you going to use the quadratic formula? Should use it. One neat thing about the quadratic formula is it always works for any kind of quadratic equation. So like some you can't factor, and sometimes it's hard on completing the squares when there's an odd number for the b. This will always work. Sometimes factoring is easier though. So like this case, it might be easier for say, oh, that's just x plus 4 times x plus 6, and then my two solutions are x equals negative 4 and negative 6. So factoring can be easier sometimes. So you could still quadratic formula, but it might take you longer. And then completing the square will always work, but when the b is odd, sometimes you'll have fractions to deal with. And you can always do it with completing the square, but I think sometimes you might have difficulty with it. But if you like doing that, go for it. Do whatever way you feel comfortable with. Let's try some examples. Pause the video. Alright, I'm going to simplify these radicals right here. So the first one is going to be the square root of 180. So I'll make the step method. So I can divide that by 2. You get 90. You can divide that by 2 and I get 45. Divide that, it ends with a 5, so I'm just going to jump to 5 right now. And then I'm left with 9, and 9 is divided by 3 and 3. So I circle my pairs, square my alone. On the outside, I will have a 2 times 3. Inside, I'll have a 5, so that becomes 6 radical 5. That's my answer. Next one, 54. Make a step, that's even, so divide by 2. I get 27. 27 is divisible by 3. You get 9, and 3 and 3. I will circle my pairs, square alones. So I'm left with 3 on the outside, and 2 times 3 is 6 on the inside. There's the answer. Pause the video. So I'm going to solve using the quadratic formula. So my a in this case is going to be the coefficient 1, b is going to be 9, and c is going to be negative 8. So plugging those in, I get x equals negative b plus or minus the square root of b squared, so 9 squared, minus 4 times 1 times negative 8, all divided by 2a. Plugging that in, I get negative 9 plus or minus 9 squared is 81. 4 times 1 times 8 is 32. Since there's two negatives, that's positive 32 divided by 2. Inside the radicand, it's negative 9 plus or minus 81 plus 32 is 83. Square root of 113 divided by 2. And you can't simplify any more than that because 113 is prime. You're done. All right, that's it.